Electric potential due to electric dipole at any general point. The students, we will study in this class the potential due to dipole at any general point, which is not axial, which is not equatorial. So first of all, what we know, electric dipole is the combination of two equivalent opposite charge. This is minus q, this one is plus q, this is the center of the dipole, and this separation between these two charges is called length of the dipole. We can check in previous lecture. From center, any general point P, which is at the distance r and making angle theta with the direction of dipole moment, which is towards the positive q charge. What we need to find? Potential due to dipole. It means potential due to both the charge we need to add here. This is the separation of point P from the positive q charge, and this is the separation of point P due to second charge. Okay, so this is r, this is theta, this separation is d. It means this whole separation is d, this one is d cos theta, d by 2, this one is d by 2. So we will here, this is point P, this is O, this can be written as B point, and this is A point. Okay, this A and B point. From here to here, this is R separation. And we need to draw the perpendicular on the position vector from the charge, positive charge, and from the negative charge. यहाँ से यहाँ तक. This is the, it means you can see this is 90 degree, this is d by 2, and this one will be d by 2 cos theta. This one will be d by 2 cos theta. And this is, we can write m, and this perpendicular point is called n. So this is, hold is d, this is d by 2, this one will be the d by 2 cos theta. What will be? D by 2 cos theta. This length is. Okay, the potential at point P, total, net potential due to dipole at point P. So V equals to, that is K Q. It means we can write V due to positive charge plus V due to negative charge. So we can write V due to positive charge is what? KQ by, separation is AP. Separation is AP. And this is due to negative charge is negative potential. So we add and it will becomes negative. We can write BP. BP. In this separation, in this AP equals to PM. Taking it from diagram. For small dipole, what we can write? AP approximately equals to MP. This MP equals to, you can see, OP minus ON. What you can write? OP minus ON. You can see here OM. You can see here OM and ON. Magnitude wise equal. This is D by 2 cos theta. Okay. This is D by 2 cos theta. This is D by 2 cos theta. So what is here? D by 2 cos theta. OM. ON is d by 2 cos theta, and d by 2 cos theta, d by 2 cos theta, OM minus ON. Here OP, you can see students, this is R, so this is R minus d by 2 cos theta. Now you can see this OB and ON, BP and MP equal approximately. Right now, base or hypotenuse will be equal. Like BP approximately equals to what? NP. NP you can see OP plus ON. OP plus ON. What is OP? OP is R. What is ON? ON is D by 2 cos theta. Any problem? So you can write AP and BP, this and this. So V equals to, you can write KQ is in both. So we can take common. We can write 1 by R minus D by 2 cos theta and minus 1 by R plus D by 2 cos theta. Okay, so V we can take here. V we can take. Downside is not visible, so we can write over here, right here. V equals to, this is KQ, right? And this is LCM is A minus B into A plus B, that is A square minus B square, and here multiply like R by 2, R D by 2 cos theta minus R plus minus of minus is plus D by 2 cos theta minus R plus R is cancelled. So V we can write here. V what we can write? KQ D by 2 cos theta, D by 2 cos theta, like half cos theta, half D cos theta, half D cos theta, D cos theta, D cos theta. So we can write R square minus D square by 4 cos square theta. Okay, so this V equals to QD is P na. What we know? We have what we have? P equals to Q into D. We know electric dipole moment equals to charge into separation. You can check over here. Any problem? Simply what we did, potential due to positive charge, KQ by separation. Potential due to negative charge, KQ by separation. Negative hota hai potential. So sum is like, we can AP reduce in the form of R and D and cos theta. So this is, and we only add this one, right? So the situation, this will be the KQ D cos theta. So we can write here, I'm erasing over here, you can pause and write down. This is very important formula. From here you can find all the standard value also for the potential due to dipole in axial and equatorial point too. So here V equals to KP cos theta by R square minus D square by 4 cos square theta. लिखेंगे for small dipole, in that if R is very greater than D, then we can write R square minus D square is by 4 is approximately equals to R square. Now the V is, then V equals to KP cos theta by R square, and where K is 1 by 4 pi epsilon naught na, so V equals to 1 by 4 pi epsilon naught P cos theta by R square. Here what is P? Dipole moment. What is theta? Is the angle between the position vector, this is R, and dipole moment vector, this is P. This is the theta. ओके, एनी प्रॉब्लम? यहां पे आप ध्यान से देखें, ठीक है? अब ये जो वैल्यू है ये हो जाएगा, दिस विल बिकम्स जनरल वैल्यू. We can say what is the general value, sir? If you will take theta over here, this will be the point. You can take point here, 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 here. You can take point at any you can find potential at any point. It means if this is the point, you draw over here, and this is the theta, this is the positive. From positive, this is whole theta you need to take. Okay, so this is the potential due to. We can write from here special point. Yes, special case. This is done, everyone. This diagram is very important in order to derive the potential due to dipole at any general point. ध्यान देंगे, this will be very easy. There is no any difficulty. You need to understand, and this general formula you need to remember. Okay, general formula you need to remember. Okay, so especially this is general. General means what? General means all the points included in general. This general formula will be satisfied all the special point also. It means all the points is at any point we can find the potential from this formula by taking suitable given r and theta, theta and r, right? So special case from here, special case we can write case 1 लिखेंगे potential due to dipole at any axial point. Potential due to dipole at any axial point. This is minus q and this one is plus q. This is the center of the dipole. This is the separation between the charge, and this is the general point P. This is general point, na? This is special point. If this is theta, you can take reduce theta to 0. You will take theta equals to 0 for axial point. If you will take theta equals to 0 at axial point, then cos, we can write V equals to what? We have V equals to Kp cos theta by r square. Then V axial we can find, students, that is Kp cos 0 by r square. Cos 0 is 1. So V axial is what? Kp by r square. K into P by r square. Why? Because cos 0 equals to 1. So Kp by r square, this is axial point. Right? Kp by r square, this is axial point. So axial point, what is the value of K? K is proportionality constant over here. What is the value? 1 by 4 pi epsilon naught. This is P by r square. This is the potential due to dipole at axial point. Okay, you can check over here general point. This is if you will take reduce theta to 0, it will becomes axial point. If you will increase this theta to 90, it will becomes equatorial point. For equatorial point, theta with the dipole moment will becomes 90 degree. So cos 90 is 0. So potential at any equatorial point due to dipole is always 0. Get it? Now done. Fast. Then you can pause and write down. Next, what we can see. Special case 2. Students, case 2, special case 2 लिखेंगे the potential at equatorial point. Potential at equatorial point P. So what is equatorial point? You erase this one. This is axial r separation. Equatorial point is this one, and the separation is r, and this dipole moment making angle theta with dipole moment is 90 degree. Okay, 90 degree. The potential, the theta is for equatorial point, theta equals to 90 degree for equatorial point. Equatorial point. So V equals to Kp cos 90 by R square. Then V equals to 0 at any equatorial point because cos 90 is 0. Okay, so you can see students, any point, right? Equatorial point means any point which is on equatorial line. This is minus q, this one is plus q, this one is separation, this is O point, O, and this is, you can write axial point, this is equatorial, equatorial, equatorial. Any point, at any point, this equatorial, it will making angle 90 degree and cos 90 is 0. So at any equatorial point, the value of electric potential due to dipole is always 0. And the value of equipotential surface, value of electric potential at any axial point is what? Kp by r square. That is 1 by 4 pi epsilon naught p by r square, and p is what? Dipole moment, which is the value of qd. It is vector quantity and its direction is from negative to positive. Okay, in next class we will study the potential field at any general point. Also we will see the special case at axial and equatorial point. Also we will see direction of field and potential, direction of field at axial and equatorial point, which is in the direction of dipole moment or in any other direction we will study. So watch this video completely, and this formula kp cos theta by r square will be used in the derivations of electric field at any general point. So keep in mind, watch this video completely, and if possible, if you like, if you understand the concept, you can share with your friends and with the students who can be benefited from my videos. All the best.